299,792,458 meters per second. That's the speed of light. And nothing in the universe can go faster. Nothing. Not rockets, not particles, not information itself. But have you ever stopped to ask why? Not just that the speed of light is the limit, but why there's a limit at all. What is it about the universe that puts up this wall? Most people shrug and say, well, Einstein figured it out, relativity. That's just how nature works. But that's not really an answer. That's just a label. When you actually dig into this question, when you refuse to accept the label and demand to know what's really going on, you stumble into something extraordinary, something that rewrites everything you thought you knew about space, about time, about the very fabric of reality. The speed of light isn't some arbitrary speed limit posted by the cosmos. It's not a rule imposed from outside. It's a window into the deepest structure of space-time itself. And once you see it, you can never look at the universe the same way again. Let me show you what I mean. Let me tell you a parable, a story. And this story reveals exactly why the speed of light is the limit. Once upon a time, there was a daytime surveyor who measured the king's land. He took his directions from a magnetic compass needle. Eastward separations from the center of the town square he measured in meters. But the northward direction was sacred. He measured northward separations in a different unit, in miles. His records were complete and accurate and were often consulted by other daytimers. A second group, the night-timers, used the services of another surveyor. Her north and east directions were based on a different standard, not magnetic north, the North Star. She also measured eastward in meters and sacred separations northward in miles. Her records were also complete and accurate, marked by a steel stake. Every corner of a plot appeared in her book. Daytimers and nighttimers did not mix, but lived mostly in peace with one another. However, the two groups often disputed the location of property boundaries. Why? Because a given corner of the typical plot of land showed up with different numbers in the two record books for its eastward separation from the town center. The northward measurements also did not agree. The differences were small, but the most careful surveying did not succeed in eliminating them. No one knew what to do about the single source of friction between daytimers and nighttimers. One fall, a student of surveying turned up with novel open-mindedness. Unlike all previous students at the rival schools, he attended both. At day school, he learned from one expert his method of recording locations based on magnetic north. At night school, he learned the other method based on North Star north. As days and nights passed, the student puzzled more and more in an attempt to find some harmonious relationship between the rival ways of recording location. Here's what he did. First, in defiance of tradition, he took the daring and heretical step of converting northward measurements from miles into meters. The northward direction was no longer sacred. He used the same unit for both directions. Then he tried combining the measurements in different ways. He had heard somewhere of the Pythagorean theorem that the sum of squares of the legs of a right triangle equals the square of the hypotenuse. And he discovered something remarkable. If you take the northward separation, convert it to meters, square it, then take the eastward separation, square it, and add them together, you get a number. And that number is exactly the same for both surveyors. The daytime surveyor records different eastward and northward numbers than the nighttime surveyor. They look at the same steel stake and write down completely different coordinates. But when you combine them using the Pythagorean theorem, you get the same answer. The student called this the distance, and he said he had discovered the principle of invariance of distance. He reckoned exactly the same value for distance from daytime measurements as from nighttime measurements, despite the fact that the two sets of surveyors' numbers differed significantly. It didn't matter which direction you called north. It didn't matter which surveyor you asked. The distance was the same for everyone. This seems obvious now. Of course, the distance between 2 points doesn't depend on which direction you call north. That's just geometry. But the student showed something deeper. He showed that even though the individual measurements disagree, there's something they all agree on. Something invariant, something real. After some initial confusion and resistance, daytimers and nighttimers welcomed the students' new idea. The invariance of distance, along with further results, made it possible to harmonize daytime and nighttime surveys. Everyone could agree on the location of each plot of land. In this way, the last source of friction between daytimers and nighttimers was removed. Now, what does this have to do with the speed of light? Everything. This parable explains what Einstein discovered about space and time. Because before Einstein, we had the same problem with space and time that the surveyors had with north and east. We thought space and time were separate, independent. You measure space with rulers, you measure time with clocks, they have nothing to do with each other. But then we started measuring the speed of light, and something very, very strange happened. You're standing still, you shine a flashlight, you measure the speed of the light coming out, 299,792,458 meters per second. Fine. Now, you get on a train, a fast train, moving at half the speed of light, you shine the flashlight forward in the direction the train is moving. Common sense says the light should now be traveling at the speed of light plus the speed of the train. Just like if you throw a ball forward from a moving train, the ball moves faster than if you threw it standing still. But that's not what happens. You measure the light. It's still traveling at 299,792,458 meters per second. Exactly the same speed. You say, okay, maybe I measured wrong. So you get the train going even faster, 90% the speed of light. You shine the flashlight forward, you measure, still 299,792,458 meters per second. You get frustrated, you get the train going at 99.9999% the speed of light, you shine the flashlight, you measure, still the same speed. The speed of light does not add, it doesn't combine with your speed. It's always the same no matter how fast you're moving. This should break your brain. This is not how speeds work in everyday life. Speeds add if you're on a train at 50 miles per hour and walk forward at 3 miles per hour, you're going 53 miles per hour relative to the ground. But light doesn't do this. Light always moves at the same speed relative to you, no matter how fast you're moving. This is exactly like the surveyor problem. Two observers moving at different speeds measure different things. One says the light traveled this far in this much time. The other says it traveled a different distance and a different time. They disagree on the space separation. They disagree on the time separation, just like daytimers and nighttimers disagreed on northward and eastward. But here's the key insight. There's something they agree on. Just like the student surveyor found that distance was invariant. If you combine space and time measurements the right way, you get an invariant, something everyone agrees on. I call it the space-time interval. Let me explain how this works. The student surveyor found that invariance of distance was most simply written when both northward and eastward separations were expressed in the same unit, the meter. The same thing is true for space-time. Invariance of the space-time interval is most simply written when space and time are expressed in the same unit. How do you measure time in meters? You multiply by the speed of light. Light travels about 300 million meters per second, so 1 second of time equals 300 million meters of time. 1 nanosecond equals about a third of a meter. Once you've converted time to meters, you can combine space and time measurements. And here's where it gets strange. But here's the strange part. The formula isn't like distance. It's not the square of time plus the square of space. It's the square of time minus the square of space. That minus sign changes everything. For the surveyors, northward squared plus eastward squared equals distance squared. Both directions contribute positively. You add them together. For space-time, time squared minus space squared equals interval squared. Space and time work against each other. You subtract. This is not arbitrary. This is not a mathematical trick. This minus sign is telling you something deep about the structure of reality. Space and time are not the same. They're woven together, yes, but they point in opposite directions in some fundamental sense. Here's how I think about it. You're always moving through space-time at a constant rate. You can't speed up. You can't slow down. You're always moving through space-time at the same total speed, but that motion is divided between space and time. You're sitting still, not moving through space at all, and all your motion is through time. You're moving into the future at maximum speed, 1 second per second. That's as fast as you can move through time. But if you start moving through space, you have to steal some of that motion from time. Your total motion through space-time stays constant. So if you're now moving through space, you must be moving through time more slowly. The faster you move through space, the slower you move through time. Let me say that again because it's so strange. You have a fixed budget of motion through space-time. You can spend it on space or you can spend it on time, but you can't exceed the budget. If you spend more on space, you have less for time. That's time dilation. It's not a trick. It's not an illusion. It's not something that just appears to happen. Time actually slows down for moving objects. Their clocks tick slower. Their atoms vibrate slower. Everything about them runs slower. And there's a maximum. If you could move through space at the speed of light, you would have zero motion left for time. Time would stop for you completely. You would be spending your entire motion budget on space with nothing left over for time. This is why light doesn't experience time. From a photon's perspective, it's emitted and absorbed in the same instant. No time passes. A photon traveling from a distant galaxy to your eye experiences no time at all. To the photon, the emission and the absorption happen simultaneously. The universe is frozen. You can't go faster than light because you can't have less than zero motion through time. That's the limit. That's the wall. I summarize it like this. Space-time tells matter how to move. Matter tells space-time how to curve. The speed of light isn't a speed limit imposed on the universe from outside. It's built into the structure of space-time itself. It's the conversion factor between space and time. It's the rate at which cause and effect can propagate. Light happens to travel at that rate because light has no mass. But the rate itself is a property of space-time, not of light. If light didn't exist, the speed limit would still be there. Now, here's where it gets even stranger. If you try to accelerate something to the speed of light, something weird happens. The closer you get, the harder it becomes to go faster. It's not that you run out of fuel. It's not that your engine isn't strong enough. It's that the object itself resists acceleration more and more. As you approach the speed of light, the energy required approaches infinity. To actually reach the speed of light, you would need infinite energy. So nothing with mass can ever reach the speed of light, not because of some arbitrary rule, not because of engineering limitations, but because the structure of space-time itself prevents it. Massless particles like photons can travel at the speed of light. In fact, they must. They have no choice. They're always moving at that speed. But anything with mass can get close, very close, 99.9999% of the speed of light, but never quite there. The universe won't let you, and here's the beautiful part. This isn't just theoretical. We've tested this over and over and over. Particles in accelerators get pushed to 99.9999% the speed of light, and guess what? The closer they get, the harder it becomes to accelerate them further. You pump in more and more energy, and the particle barely speeds up, exactly as predicted. The energy goes into increasing the particle's inertia, not its speed. GPS satellites have to account for time dilation. They're moving at about 14,000 kilometers per hour. That's not close to the speed of light, but it's fast enough that their clocks tick slightly slower than clocks on the ground. They're also in a weaker gravitational field, which makes their clocks tick slightly faster. The two effects don't quite cancel. Time passes differently for them than for us. If we didn't correct for this, if we didn't account for Einstein's relativity, GPS would be off by kilometers within a single day. The fact that GPS works is proof that relativity is right. Muons created in the upper atmosphere by cosmic rays provide another test. Muons are unstable particles. They decay. Their half-life is about 2 microseconds. In that time, even traveling at nearly the speed of light, they should only travel about 600 meters. They're created 10 kilometers up. They should all decay long before reaching the ground. But they don't. Many muons make it to the ground. Why? Because they're moving so fast that time slows down for them. From their perspective, they live long enough to reach the ground. From our perspective, they live longer because they're moving fast. Either way, more muons reach the ground than classical physics predicts, exactly as relativity predicts. It's not speculation. It's measured. Every minute of every day, particle physics experiments demonstrate this. The speed of light being a limit is as well tested as anything in physics. I call this the principle of invariance. Just like the student in the parable found that distance was invariant even though eastward and northward measurements disagreed, Einstein found that the space-time interval is invariant even though space and time measurements disagree. And that invariance, that minus sign in the formula, is why there's a speed limit. You can't go faster because going faster would require moving backwards in time. The minus sign prevents it. You can't have negative time. You can't undo cause and effect. The speed of light is the speed at which now propagates through the universe. It's the speed at which information can travel. It's the speed at which forces act. It's the maximum rate of change. I've spent my whole life looking for what I call the idea so simple, so beautiful, that when we grasp it, we will all say to each other, how could it have been otherwise? He believed that at the bottom of physics, there's something elegant, something inevitable. And the speed of light being woven into the structure of space-time, that's part of that elegance. So let's bring this together. Why is the speed of light the limit? Because space-time has a geometry, and that geometry has a built-in conversion factor between space and time. That factor is the speed of light. When you move through space, you trade time for space. The faster you go, the more time slows down. At the speed of light, time stops completely, and you can't go beyond stop. The surveyors in the parable disagreed on northward and eastward, but they agreed on distance. We disagree on space and time, but we agree on the space-time interval. That agreement, that invariance, is what makes physics possible. It's what makes the universe comprehensible. It's what I call the great unity of space-time. And here's what I want you to understand. This isn't just abstract theory. This is the actual structure of reality. The space you're sitting in right now, the time passing as you listen to this, they're woven together, they trade off against each other, and the speed of light is the exchange rate. As I like to say, we live on an island surrounded by a sea of ignorance. As our island of knowledge grows, so does the shore of our ignorance. The speed of light opens a door. Through that door, we found space-time. Through space-time, we found black holes, gravitational waves, the expansion of the universe. Each discovery building on the last. Each new insight opening doors to more insight. That's how science works. That's the process that's been going on for 400 years. And we're still making discoveries at high speed. The speed of light isn't just a number. It's the key. It's what unlocks how space and time actually work. It's what shows us the universe is stranger and more beautiful than we ever imagined. And the fact that we can understand it, measure it, test it, use it to make predictions, that's the beauty of physics. Not comfort, not simplicity, truth,